In the last class that I have delivered, in that class we discussed about Bohr's atomic model. I don't know how many of you were there. I think maximum of you were there in that class. Around 17 people were there. Okay. So exactly Manotna, Ketaman Monster, Raisa was there, Simias Vidyati Asila, then Vigyan, Sarfaraz, Maskor Asila, nothing there. Video site, okay, recording site, that's enough. Recording to network and anyone worry so that they can download later and check the video. Okay, no issue. Raisa Ajimat Wako internet Hayasu. Okay, just for the benefit of those people who are at home. So we have to shift to the Airtel. Okay. So in that class, we discuss about how the Rutherford did the mistake by saying that your what is called atoms can collapse, the electron can fall into the nucleus, and we have discussed already. You can see the recording, and there I calculated the potential energy. और तुम्हारा कोई सुनो जे calculate कोई दिबा. You just please calculate total energy of the electron. Have you calculated? मैं just कोई दिला जाना जैसे कोई सिला. So you got some answer to that, na? So first of all, here the total energy, is it okay? The total energy will give you a negative value. Okay? The total energy gives you negative value. So negative value of energy means what? Negative value of energy is not accepted, but here we get negative value of energy. Aru ko baat paitla demano ke negative value of energy? In quantum mechanics, what? Negative value of energy? Type 1? Type 1. Nothing. So positive yes. What? In any system, you have studied so many systems, no? Classical physics to Polila, quantum mechanics of Pohisa. So in maybe in optics Pohisa, here Pohisa. And in most of the cases, we always calculate the energy, isn't it? Energy is the prime thing for us. Because any system, we can understand the system when we come to know about its energy. So nowhere you got negative value. So you got negative value in this case. Let me write the complete expression. Isn't it? You people will exam, no? So you need to remember the formula. Okay, let me write the formula here. The energy En is equals to minus of mz square e to the power 4 8 epsilon naught square h square. मैं लिखि रखम बेका गुसी जाऊ दे एटु मोर अभ्यास আছে মই বহি লিখা সময়তে বেকা গুছি যাও ओके মই সদায় ওপৰ ফালে যোৱা অভ্যাস আছে লিখা সময় So the energy value is coming like this: minus of mz square e to the power 4 8 epsilon naught square h square into 1 by n square. ठीक है सर तुम्हारा calculate करिबा the last class recording saba check that recording and calculate this value. Okay, this file alive and while doing that calculation in between to calculate koribo like radius of hydrogen atom in terms of n, small n. What is small n? What is small n? Aru bhallam? Quantum number, physical number, quantum number. N is your quantum number, isn't it? and n value goes from 0 or 1. Why not 0? 0 ho pare quantum number. Do you remember simple harmonic oscillator? Kor poisila simple harmonic oscillator? Simple harmonic oscillator eroka thake. We will study that in molecular physics. Simple harmonic oscillator, if I need to write the energy En, that will be n plus half 8 cross omega. This is the energy of a simple harmonic oscillator. It was some molecular physics. Okay, we have a system called vibrational spectroscopy. So here my n value 0 hobo pare. Taka ami 0 point energy boli kom. If n equal to 0 hoye jabo, energy kiman aibo half h cross omega. That is known as 0 point energy in simple harmonic oscillator. And remember, each and everything is this universe is vibrating. Is vibrating. Even at T equal to 0 Kelvin, a system will have 0 point energy. Taka ami 0 point energy. N equal to 0. It requires vibrational spectroscopy. Okay, we all are vibrating, and this vibration will increase with the temperature. Demand temperature will have even vibration. Vibration and heat both are same thing. Same thing in what respect? Same thing means vibration at an energy high, and when we say energy, it will fall to a frequency level: microwave, radio wave, infrared, UV, gamma. What these are things? These are different ranges of frequency of spectra. He represent correct. They represent different forms of energy, different levels of energy, isn't it? Similarly, vibrational system the vibrational spectra that will fall in your infrared. Into our infrared region. Okay, their frequency around 10 to the power 12 hertz. A2 range of tomorrow vibrational spectra ahead. 10 to the power 12 or 10 to the power 14 of the frequency hertz. After 10 to the power 14 we have ultraviolet. After 10 to the power 16 we have X-ray. Now after 10 to the power 18 we have this gamma ray and all. Okay, so different ranges carries different name. Of course, infrared, microwave, radio wave, telephone use kora ki radio waves, isn't it? Remote control use kora TV. What are those things? Microwave. I got a microwave because you might do infrared wave because infrared. Oh, more than 2 ঘন্টা লাগিলে সেটআপ কৰিব কাৰণে এতিয়া মই অনলাইনও আছো অফলাইনও আছো আপোনাৰ 8:30 আছিল হয় আপোনাৰ 8:30 সফটৱেৰ হয় মোৰ 10:30 এই আপুনি চেঞ্জ কৰিলে নহ'ব না এই 8:30 নহয় এই আপুনি নিজে ঘৰ পাই চেঞ্জ কৰিলে নহ'ব এই কথা বুজিছান বুজি Okay, so we have different forms of frequency level. That means I'm going to keep here. So I'm going to atomic spectra. This paper's name is atomic physics or whatnot. But generally we will study here the spectra. Spectra key hai? Spectra are the fingerprint of different energy level of your system. We have fingerprints, na? These fingerprints identify you. If model order kori aha, age jabon fingerprint revolver ba knife abar edu track kori kine tumar track kori jeno lo jabo, isn't it? So fingerprint track kori poi deneke. So similarly, ago fingerprint hide kori poi na. People use gloves and different things. Na? Similarly, these electrons, when they are moving around the nucleus in different energy levels, they will also give their fingerprint. And these spectra levels are their fingerprints. Okay. If they are rotating like this, if the system is rotating like this, then they will give rotational spectra. Microwave. If they are vibrating, they will give you vibrational spectra. That will fall in infrared. And if we are there transiting, we are studying here transition from one level to another level, then they will give you visible or UV light. That will fall in that spectra. Okay. So here vibration, rotation, that will come into play when you talk about molecule. Single atom or vibration rotation I am studying about, because that doesn't have any kind of significance. Okay. So when we talk about molecules, then we talk about rotation or vibration. ठीक है sir? And that part we will discuss in molecular physics. Here we will purely talk about an atom which has electrons. In molecule we combine two atoms, 2, 3, 4 atoms. ठीक है sir? Now spectrum of already called it's a fingerprint of your what is called energy levels of electron or atom G coordinate. Electron energy है atom energy. ठीक है sir? So we all people are vibrating and we all are emitting a vibrational spectra. So what about? Okay, we all are carrying that. And your this heat, I mean যে কোন সিস্টেম হিট হয়ে গেছে কি হয় ইন্টারেস্টিংলি হিটর যোনটো frequency range সেটো ইনফ্রারেডে পড়ে. That means if you are heating a system, that means you are allowing it to vibrate too fast. When system vibrates, it will radiate the heat. When it vibrates, it will radiate the heat. That means if I say heat wave or vibrational wave, because both fall in the same energy region, which is infrared. Okay, system garam means what? You are vibrating the system too hard. You see here, too many things involved. If I am talking about atomic physics, I cannot talk about only atomic physics. Some part of molecular physics will also involve there, and some part of your condensed matter physics will also involve there, and some part of your thermal physics will also be involved there. Because you have to link different things. Okay, to me statistical physics ki kobo tomar, when you have too many numbers of atoms, then how will you study their energy levels? Too many atoms in a room, you have a cylinder and you have too many atoms there, so how will you study their energy levels? Okay, hetu tumi study koriba statistical physics. Condensed matter ki kora, condensed matter, all the atoms now interacting with each other, they have formed a bond. They are a bond form koreche, covalent ho pare, ionic ho pare, jikono bond ho pare. So how now they will interact, and now what is the energy output of the system? Hetu hoy condensed matter. ঠিক আছে? In statistical mechanics, you study the energy of the whole ensemble. But system or energy তুমি চাব লাগিব, এটা assemble কৰিলা সব energy. Suppose you people, I've assembled you in this room, I need to calculate the energy of the system. So I'll go by statistical mechanics. But if the people start to fight with each other, এটা আমি তাক সরিয়ে দিলে, এটা ঘুষিয়ে দিলে, so the system's energy বেলেগ হৈ গ'ল এতিয়া. Isn't it? Now I will go to condensed matter because you all are interacting with each other. And I'll try to find out the total energy of the system using condensed matter or solid state physics. Okay? And in atomic physics, what I am doing? I am singly studying a single person. It's only one atom I am studying it. Baki no partition. There's a difference between solid state and atomic physics. In atomic physics, we simply study the property of a single atom. But remember, a single atom is nothing. Kono kaam nahi. Okay, we just study it, but iska kono kaam nahi. Application of solid state condensed matter physics se aaye. Atomic physics is a pure physics. We are just trying to understand the characteristic of a single atom. Okay, and whole study in this whole paper, ami theory bahut theory podhim yaar, but the basic idea is always to relate with the experiment. Experiment data ji dibo ama. If our theory is matching with that data, then well and good. If that data is not matching with the theory, then we will modify the theory. Because the experimental result is the final verdict. You cannot go beyond experimental result. Okay, চকুৱে দেখা হৰাই ধৰি থাকে. So you will accordingly modify your theory. So initially the Rutherford theory, we know experimentally that atom never collapse. The system is always there. Na? If I leave this bottle on this table forever, it will remain there forever. If no external force acts on it, কোনো ধৰণৰ tsunami, earthquake যদি নাহে, it will be remain there. It will not collapse. It will not collapse. So that was the problem in the Rutherford theory. So Bohr dealing with your model, that was a modified version of Rutherford. He included quantum number and all. And he said that electron will not radiate energy while moving on the circular path. কিন্তু এটি তোমার কৈছিল Rutherford মতে, because Rutherford is simply electrodynamics follow কৰি আছিলে, which you are studying this time. তাত তুমি theory মানে পেপাৰৰ লাষ্টৰ ফালে দেখিবা that an accelerated charge body will radiate energy. There is a topic in the later part of your paper. So accelerated যেতিয়া the charge body move করে, accelerated মানে move কৰিছে আৰু, it will radiate energy. Okay, তা তুমি পাবা, you will calculate pointing vector and all those things there. So hey principle to use কৰিছিল Rutherford, but that thing found to be not valid according to experiment. Atom to collapse হৈ যোৱা নাই. So Bohr very cleverly modified for it. He was very clever. Okay, sometimes you need to be clever as well. So cleverly modified for it. Well and good. Then we got this energy value. I have written there, na? Energy En is equal to minus mz square e to the power 4 by 8 epsilon naught square x square into 1 by n square, where n is your quantum number. And while deriving this equation, I have already asked in the last class that please calculate the velocity and as well as the radius of the atom with respect to quantum number n. তোমাক কৰিবলৈ কৈছিলো লাষ্ট ক্লাছত, যদি কৰি চাও ঠিক আছে. So let me write those expressions. ইমানে দীঘল expression মোৰ থাকে মনত. So let me write those expressions. So your radius was equals to n square h square epsilon naught divided by pi m z e square. This is your radius of nth level, and the velocity having the quantum number n is z e square divided by 2n h epsilon naught. Okay, these are the values. These are the values. Now, as you can see here, your this part, the radius part, it carries the quantum number n, and similarly your velocity part also carrying this quantum number n. Velocity code বেশি হয়, n equal to lower orbit or higher orbit? Velocity code বেশি হবো, lower orbit or higher orbit? Lower orbit. Is inversely proportional to what? He is inversely proportional to n. That means if I increase the n number, velocity will decrease. That means the maximum velocity the electron can have, it is in the first orbit, n equal to 1. Okay, and that falls around, if you put all the values for hydrogen atoms, they put your value, you can put the value of charge, Planck constant and epsilon naught, we will get around 10 to the power 6 meter per second. I'm just telling you the order. The order will be around 10 to the power 6 meter per second in n equal to 1 orbit for hydrogen atom. ঠিক আছে? And light ray speed কিমান আছে? Order 10 to the power 8 meter per second. That means the electron in hydrogen atom can have at maximum 10 to the power 6 meter per second. Okay. So here 10 to the power 6 or if a lighter speed 10 to the power 8. So kiman percent whole speed of light? Kiman hobo? Means electrons speed is 10 to the power 6 maximum in hydrogen atom and light speed is 10 to the power 8 meter per second. So here electron speed to kiman percent of light speed ho? 0.1 hobo ne? 1 to hobo. Kiman 0.1%? 0.1% hobo ne? 2 degree কম আছে না 10 to the power 8 হওয়ার কারণে 10 to the power 6 আছে তো 100 কিমান হ'ব 1 আহিব তো 0.01 হ'ব তেতিয়া 1% ওলাই আছে 0.01 আহিব 10 to the power 2 degree so that means মই তোমালোকক কৈছিলো আগতে when some object has a speed around 8 to 90% of light speed then you should go for relativistic correction. Have I said it earlier in the last summation? When the speed of anything goes around 85 or 80 to 90%, then it's better to use relativistic approach. When we solve I think in quantum mechanics that energy E is equal to p square c square plus m naught c to the power 4. That is more question. While deriving that Dibrugarh wavelength. That কেতিয়া আমি relativistic use করি কেতিয়া আমি non relativistic use করি there I think I remember I have said that when something object speed goes around 90% or 80% of the light speed then it's better to go for relativistic correction ঠিক আছে so now here it is not 80 90% it is বহুত কম আহি আছে 80 90% হ'ব কাৰণে কিমান order same হ'ব লাগিব অলপ সেন্টাৰ পৰা এটাতে যাব লাগিব that means the electron moving here in the first orbit it is not moving with a relativistic speed. Is it moving? No. That means we don't need any kind of relativistic correction. Isn't it? We don't need any kind of relativistic correction. But remember, for whom I am saying this? I am saying for the electron which is moving in n equal to 1 orbit in hydrogen atom. Z equal to 1. If I change that, if I go at higher atomic number, remove what is your table level, then the Z value will increase. Z value will increase means velocity will increase. Directly proportional, isn't it? N equal to 1 going to up. That means if I am talking about a high atomic number element, then this electron might reach that level. Jot more relativistic correction used to be. Okay, this is one of the problem with the Bohr's theory. Bohr's theory to me relativistic correction use nakoda. You simply use this velocity, you calculate kinetic energy half mv square, you have this radius, you calculate your potential energy which is Z e square plus 4 pi epsilon naught r. ठीक है sir? And you do the get total energy value upon. Here you don't use any relativistic ahija mane ki mass is not remain m. It will become m naught by 1 minus v square c square root over. Mass change is relativistic. But here you will not tackle those things. Because this is purely done for hydrogen atom. And this theory cannot be used for those atoms which is higher atomic number. First limitation compare here not relativistic approach. That's why it cannot be used for higher atoms. Higher atomic numbers of atoms. ठीक है sir? That limitation. That means here limitation also means what? We need another theory to tackle that limitation. Any theory, when you get a limitation, you will bring another theory to tackle that limitation. Again, that theory will give you some limitation somewhere. Again, you bring a new theory. That's how the atomic physics progress. First, we'll discuss Rutherford scattering. Then we'll discuss Bohr. Then we'll discuss the reduced mass effect. Then we'll discuss Sommerfeld. Then we'll discuss relativistic Sommerfeld. Then we'll go for vector atom model. That will be purely quantum. Atomic number high value getting a pale. Hey, velocity to bonus possible. V equal to Z. Z means atomic number. So if you go to higher atomic number element, that value by going to give বুঝি পারেন না? For hydrogen, the velocity is coming at 10 to the power 6 meter per second order. যদি মই লিখো z equal to 100 করে দিও into the হবে না, you enter the light speed, then there is a velocity to হবে, there mass থাকে আর you cannot use m, then you have to use what? M equal to m naught by root over 1 minus v square by c, isn't it? So these are the some glitches here and there. You make them not believable. Are you getting my point? এই ভিতর কথা অলরেডি জানা কনসেপ্ট এটা ইউজ করা, ইউজ করা, লজিক ইউজ করা, রিমোটকেলে রিলেটিভিস্টিক ইউজ করা, কেতিয়া মই কৰিব পাৰিম এইবোৰ ইউজ কৰিব লাগিব। নাও এতিয়া ডিসকাশন কৰি থাকোঁতে ক'ৰবাত মই কিবা ভুল কৰিছোঁ নেকি? Yes, I am doing one thing. মই এটা ভুল কৰি আছোঁ কি? I am not considering that nucleus is moving. In my system, nucleus is stationary. তুমি কিন্তু ললা এটা সার্কেল বনাইছা, ভিতৰত নিউক্লিয়াস থৈ দিছা, ইলেক্ট্রন is moving and you are saying electron velocity is this, but nucleus can also be moving its own path. We are not tackling that. Have you studied center of mass system in mechanics? Center of mass system পড়িছিল, তারপর কি কয় রেফারেন্স সিস্টেম পড়িছিল। So if I see nucleus as stationary and electron is moving, then this theory is okay. But what happens if the nucleus is also moving? Nucleus is moving, electron is moving, isn't it? Or change हो उसको क्या? Stationary nucleus or moving nucleus, there is a difference. What difference? There is a thing called rotor. Rotor means, have you seen dumbbell? Dumbbell देखी था ना? टीवी देखो देखी था, कौवा देखने रिमोट देखियो पड़ा, बिल रिमोट कैसा? Dumbbell दूसरा जो मार इसे क्या ना, इधर मैंने सर्कुलर सेक्टर था क्या ना वस्तु तो? Okay, now you think, suppose this is, you have a ball here, you have a ball here, and I am moving suppose this like this, and grass, it movement, ठीक है? एटियो घुरी আছে, इयो घुरी আছে. So now if I need to calculate the mass of the system, but if I need to calculate the kinetic area, what is the moment of inertia of the system? Okay, it cannot be simple this m1 plus m2. It will go what? Now I will go for a thing called reduced mass. Koisa, reduced mass. This is koisa. I think what koisa? Mechanical koisa. Maybe in center of mass they koisa reduced mass. Why this concept come reduced mass? If one is stationary, other is moving, then there is no problem. But if both are moving, if you say a rotor, then you bring the concept of reduced mass. Here I will use for another. I am going to nucleus is stationary, completely at rest. But it is not. Nucleus is moving. Okay. So that part will be tackled in next section, which I will discuss tomorrow. Okay. Now, heat was the key changes. What changes it can bring? See, in your energy formula, what are the things there? Mass, you have atomic number, you have charge, epsilon naught, Planck constant, and this quantum number. ठीक है सर? Atomic number तुम्हारा z equal to 1 value hydrogen का ना, फिर area कौन देगा? Charge will not change. Electron charge भी होते जो आ, दोनों reference system में जो आ, it remains same. Electron charge is not related to velocity, purely constant thing. ठीक है सर? Charge की जो change जो है, तो charge में बात किया. और कि epsilon naught is a constant, Planck constant is a constant. These things will never change with even with the frames of reference. How change होगा? Same thing है. Change की होगा पड़ेगा. यह change हुआ part of your mass. If you are moving at a relativistic speed, mass can change. And if you consider that nucleus mass also, that nucleus is also moving, not stationary, then that mass will be replaced by reduced mass. Okay? So when the mass m will be replaced by reduced mass, energy value will change. Change हो जाएगा energy value. So energy value मुख्य हो जाएगा. Let me go to the next slide. Okay. Suppose, let me Should I change the color of this? Make it red, na? This is visible. Bro. Can I make it more bolder? Yeah. Better? Okay. Now, suppose I get this kind of line here. This one. Suppose this is energy. Okay. This scale is energy, and this scale is your intensity. I. Intensity. Okay. Now, you see in this picture, these red lines are giving you particular energy values. X-axis is your energy value. It can be 1 joule, 2 joule, electron, so not joule, electron volt, 10 electron volt, 13 electron volt. You get line at particular levels. Na? Now see, there are two kinds of spectra. One is called absorption spectra, one is called emission spectra. Okay, when I say absorption spectra, that tomar ki hobo background to white thakibo, enoka line tu dekhiba in black. Black lines will appear here. Background white, black lines will appear here. If I talk about emission spectra, ulta koribe. Background to black hobo, line kira white ho jabe. ठीक है सर एमिशन white line dark background and in absorption white background or not dark line but not completely dark line आता मैं reason की कोई dark line है absorption but not complete dark line. Now first of all you have to understand how we measure this absorption spectrum. I mean can I measure it? What we do, suppose you have an atom here. Okay, you have an atom here. Now you allow rays of light to pass through from this side. Yeah, this atom is here. Huh? Just think about a single atom. So this way here. And this is the incident light. Okay, this incident light is passing through this atom. That side I have put a screen here. Screen. Okay. Now this light passes through this atom. Now আমি ইয়াত কি কৰি আছো energy levels কৰি আছো হাই সেকেন্ডাৰী level that suppose the electrons are at n equal to 1 level ঠিক আছে the moment they see a incoming light they will absorb that light and they will go to n equal to 2 n equal to 3 level ঠিক আছে suppose আহি থকা লাইটৰ energy টো হল -13.6 electron volt ঠিক আছে so he into light আহি আছিল 13.6 electron volt suppose he light aha pisot electron tak absorb kori upor le gusi gol gute khini absorb kori pelala diman ahisile gute khini absorb kori pelala output ki ahise ekku na input asile so light hi khai pelale output ki ahibe ekku na hai black background ahibo that is called absorption ঠিক আছে so not black background white background থাকিবলে আৰু black line থাকিব यदि इलेक्ट्रॉन n equal to 1 or पर 2 ले जंप करिते ए corresponding energy into value ए value তুমি ইয়াত দেখিবা suppose this line is giving you jump for n equal to 1 to n equals to 2 ঠিক আছে n equal to 1 or পৰা n equal to 2 jump ৰ কাৰণে suppose ই দেখায় আৰু বুজিবা তুমি এক্সেল আৰু বুজি পাবা বেলেগকে suppose n equals to 2 to n equals to 3 karne e dekhaya why I have left a blank space in between क्यों तो मैंने वो बाजू से blank space के लिए मैं continuous line को draw कर energy value energy levels aru why I have drawn like this enake ke draw karana hai ya pisot out enake why I am not drawing like this they are discrete they have a quantum number in their energy formula in the earlier slide E depends upon n if n equal to 1 suppose for hydrogen atom kiman ahe -13.6 divided by n square We have studied that formula earlier, na? I think it is that your energy En for hydrogen is minus 13.6 divided by n square electron volt. How you achieve this? You just simply need to put the values of everything here. सब value put को दिया, z equal to 1 को दिया, mass दी दिया electron mass. You will left with minus 13.6 and divided by n square to आशा already solved. Okay. So you get this value. Now if I put n equal to 1, I'll get minus 13.6. n equal to 2, 3 point की बात आएगी. That means यदि n equal to 1 over 2 double है minus 13.6 over 3 point की बात double आएगी. तो difference तो आनी है, जिमान difference था कि वो निमाने ये light absorb करी. बुझी पाइसा? दुटा level और माजो जिमान energy level gap आसे, ये जिमाने amount और light ही absorb करी वो, हेतु energy. ठीक है सर? Suppose तुम्ही ताक 1 over 100 electron volt के energy दिला. ठीक है सर? Now electron will absorb only that line, that energy value, which is corresponding to n equal to 1 to n equal to 2. माने 1 और 2 जाबो काने जिमान energy लागे, अकल हे part तो ही absorb करेगा, बाकी part तो ही दियो, ये absorb कर. Similarly, suppose you give him 15 electron volt, ठीक है सर? It will absorb only 10, माने n equal to 1 over 2 जाबो around 10 लागे. कि 10 पे absorb करो 5 to 8 5 to देखो पड़े. ठीक है सर? यदि इबिटा 21 दी दिया कि 10 पे absorb करले n equal to 1 over 2 কাৰণে আকৌ next to ही absorb কৰি লব পড়ে n equal to 2 over 3 কাৰণে তো 1 over 3 কাৰণে যোনটো যাৰ লগত মিলে আৰু কি absorb কৰিলো তুমি ক'ব নোৱাৰা কোনটো absorb কৰে. That's why for a given range you will get different lines. Those lines corresponding jumping of electron from one lower orbit to higher orbit. It can be from n equal to 1 to 2, 1 to 3, 1 to 4, or all together. The all together है इनका black line पावा तुम्ही. और कुनु value match न करे. যদি আমি দেখিবা রিপোর্ট কৰিছো দেখিবা তুমি এটা হাইড্রোজেন এটমৰ কাৰণে কৈছো n equal to 1 over 2 যাব কাৰণে যিমান এনাৰ্জি লাগে 1 over 3 ভ্যালুটো বেলেগ 2 over 3 ও বেলেগ 3 over 4 কোনো কাৰো লগত মেচ নকৰে there are gaps ইমান দুটাকে মিলি আছে. So यदि मैं 4-5 लाइन लिखि पाइछु तो मैं মানে ক্যালকুলেটর উলিয়াই লও মই গম পাই যাম আইদার 1 over 2 হইছে বা 2 over 3 হইছে 3 over 4 হইছে বা 1 over 4 হ'ব পাৰে. You never know. You can control it. You can go. তার মন গন যাই তার কথা তোমার এদিকে মন থাকে যদি বুঝিছো আর এটা তার মন যদি এনার্জি পাইছে জি মজা এটা কৰিব পাৰে. ওকে যদি পয়সা পাই যোৱা for you the money is energy, for them the light source is energy. If you get the money, you can go and eat some fast food, or chicken lo edu khao pora ani kine, ba bole moi bole paneer kham paneer khao pora, cinema khao pora. Those are your degrees of freedom. These are each degrees of freedom. Ji mon jai koi ho pare. Okay, those things first. Now in absorption spectra ki hobo output to white screen ahi खाली माजे माजे लाइन को हेराई जाबो हेराई जो लाइन किता है डार्क लाइन कोड हेराई गो electron has absorbed it. Now what will happen in emission spectra? Now electron once jump from the ground state to higher state, it cannot live at that state forever. It will live on those states for maximum of 10 to the power minus 8 seconds. 10 to the power minus 8 seconds is a very small number. যাবো পড়ে 1 over 2 যাবো suppose the 1 over 4 যাবো কারণে 10 ইলেকট্রন ভোল্ট লাগে তুমি 10 এ দিছা নি 1 over 4 উঠি যাবো পড়ে যাও পড়ে কোন কন্ডিশন নাই তার উপর ডিপেন্ড করে তুমি স্পেক্ট্রাম চাই কব পাৰিবা তুমি কোনটো কি কৰিলে কোনো তার কন্ডিশন নাই যদি তার যোনটো লগত ফিজিবল এটো গুছি যাও you cannot bound it যদি 1 over 4 এ যাব লাগিব নহয় গুছি যাব পাৰে 1 over 2 যাব পাৰে 1 over 3 যাব পাৰে এনেকুৱা হ'ব পাৰে 1 over 2 গ'ল আকৌ 2 over 3 গুছি গ'ল কি হ'ব এটা এটা ডিগ্রি অফ ফ্রিডম এটা এলাও আছে কি কৰিব পাৰে খালি এই লেভেল বোৰ যাব লাগিব মাজত যাব নোৱাৰে Okay, so now what I was discussing already. Emission spectra, yeah. So once this electron jump to a higher level, it cannot stay at that level forever. It has to come back. And it will stay on those levels at maximum 10 to the power minus 8 seconds. Okay? মানে কি মান 1 nanosecond? So 10 nanosecond? তারপর ঘুরিয়ে নিব। So 10 to the power minus 8 second is very small time. It's like a spontaneous reaction. Go or ঘুষিয়ে নিলে। Okay? তো যোৱাটো হ'ল absorption spectra, যেতিয়া ঘূৰি আহিব সি এনাৰ্জিটো কি কৰিব? Emit কৰিব। And that will be your emission spectra. Okay, now in emission spectra you will have a dark background, তাত তোমাৰ white lines form হ'ব। Similarly absorption spectra white lines form হ'ব। খালি এইবাৰ এনাৰ্জি ওলাই গৈছে প্ৰথমত absorb কৰিছে। Now the thing is that তুমি ক'ব পাৰা স্যাৰ যদি মই absorption চাই আছো এতিয়া যিহেতু 10 to the power minus 8 সেকেন্ডৰ কাৰণে সেই ওপৰত থাকে কিন্তু ইমিডিয়েটলি গুচি আহিব সো মই এইটো absorption হ'ল না emission হ'ল কি চাই আছে you can ask the question logical question so তুমি এটা light intensity পঠিয়াই দিলা light পঠিয়াই দিলা ইয়াৰ পৰা you have an atom system here passes jump but লগা ঘূৰি আহিল নহয় jump কৰিছিলে তুমি দেখিছিলা স্পেক্ট্ৰা ঘূৰি আহিব emit কৰি দিলে নহয় so এইটো absorption হ'ল না emission spectra হ'ল actually possible but thing is that when they emit in all directions you cannot ask them to emit only that side where the screen is so the common one they have emit kori diye they can emit 360 degree every direction they can emit scattered radiation bujhi paisa they will not emit only this side but absorption you can control this is atom this is incident light it is spectra okay this side is your spectra now it will go here পৰা যিখিনি absorb কৰিলে থাকি যোৱা কিটা ওলাই গুছি গলে ইফালে আহি গলে just spectra but when they emit they can emit in this direction they can emit in this direction these are everywhere okay that's why you cannot control emission while observing the absorption spectra so মই emission কেনেকৈ control কৰিম কেনেকৈ চাম to record the emission spectra you have to put your recorder all direction সব ফালে পৰা হি সিগন্যালটো ৰিসিভ কৰিব তাৰ পৰা এটা কমন সিগন্যালটো বনাব ঠিক আছে নাও অথনি মই লাইনটা ইউজ কৰিছিলো that in absorption spectra dark lines are not completely dark do you know why yeah absorption হলে line dark আহিব but কি হল যে spontaneously তোমাৰ emission হল কোনোবা এটা পার্ট এইফালে গুছি যাব পাৰে স্ক্রিনৰ ফালে আৰু যেহেতু এমিশনৰ লাইন হোৱাইট হয় ইয়াৰ ডাৰ্ক হয় এই কোনোবা এটা পার্ট যিটো স্ক্রিনৰ ফালে গুছি যাব পাৰে there is chances those dark lines after adding with those white lines become little less dark বুজি পালা এটা completely dark না in theory this should be completely dark but practical common problem আছে কারণ লগে লগে spontaneously emission হোৱা কাৰণে কোনোবা এটা part of emission spectra can go to that side where you are situated this screen for recording absorption spectra and কেলে এটো লগ লাগি যাব because emission spectra energy আৰু absorption spectra energy একে জায়গাতে পৰিব যদি n equal to 1 ৰ পৰা 4 যাওঁতে যিমান energy absorb কৰিছে 4 ৰ পৰা 1 আহোতে নি মানে emit কৰিব বুজি পালা that means for example suppose this is my your absorption spectra no spontaneously emission হোৱাৰ লগে লগে suppose let me do let me put some white color here এনেকুৱা হৈ গল নহয় দিয়া নাইকিয়া হৈ গল নহয় দিয়া দেখিছানে তাত নাইকিয়া হৈ না যায় তাত তোমাৰ কালাৰটো এড হৈ যায় red আৰু white মিলি মানে black dark আৰু white মিলি lesser dark হৈ যায় but very small percentage because emission সব ফলে যাব পাৰে if এটা part হে যাব so নিকাৰণে absorption lines are not completely dark বুজি পালা but emission spectra যোনটো আহিব completely white bright completely এটো খুলি লোৱা বুজি নাপাম নহলে dark color, not black color. Hmm. Mix. Ah. No, বুঝা নাই absorption spectra তোমার dark আহিছে dark lines বোৰ আহিছে লগালগ তোমাৰ spontaneous emission হৈ কিনে এটা part হেফালে গুচি যাব পাৰে emission এতিয়া n equal to 1 ৰ পৰা 4 যাব কাৰণে যিমান এনাৰ্জি লাগে absorb কৰিবৰ কাৰণে n equal to 4 ৰ পৰা 1 আহিলে হিমানে এনাৰ্জি এমিটো কৰি দিব হয়নে নহয় মানে এনাৰ্জি খৰচ নকৰে হিমান হি খাইছিলে হিমান উলিয়াই দিব so that means what সেই জায়গাতে পৰিব গৈ আকৌ একে জায়গাতে পৰিব so your dark and bright will mix বুঝা নাই মই absorption spectra background to white ঠিক আছে background to by default white absorb কৰাৰ পিছত হেইকিটা লাইন ডার্ক কৰিলে ঠিক আছে এলাকে বুজি পাইছা তাৰ পিছত spontaneous of 10 to the power -8 second those electrons will come down they will radiate again the emission spectra emission line হঠাৎ bright থাকে dark আছে হে dark আৰু bright বুলি মই কৈ আছো less dark হ'ব lesser dark এটো মই বুজাই আছো that's what I'm saying the absorption spectra dark lines are not completely dark ঠিক আছে but completely bright হয় না যায় because why the emission spectra will take place in all directions এই ফলে এটা পার্সেন্টেজে পড়িব এখানে lesser dark got my point yes absorption তুমি প্ল্যান কৰিছা তুমি লাইট দিলা এটমৰ ওপৰত পৰিলে ৰেকৰ্ড কৰিলা বাট এমিশন ইজ স্পন্টেনিয়াস কি গ'ল আৰু আহিল emission means the electron can stay at higher energy level for 10 to the power -8 seconds at max that everything wants to be come back to ground energy যদি মই ইয়াত থিয় হৈ আছো ডেফিনেটলি মই বহিব বিচাৰিম তব হ'ব বিচাৰিম that is my ground energy ৰাতিপুৱা যে মই উঠিলো my excited lifetime কিমান ৰাতিপুৱা উঠাৰ পৰা ৰাতি হোৱালৈকে around suppose 18 hours or 17 hours so I can be in excited state for 17 hours excited means হুই থকা নাই যদি মই হুই থকাটো ground level উঠিলো ৰাতিপুৱা suppose around 7 am to 7 am পৰা ৰাতি 10 pm লৈকে suppose around 15 hours so my excited state lifetime is 15 hours then again I go back to bed ঠিক আছে and for electron it is around 10 to the minus 8 goal খোৱা বোৱা কৰিলে ফুৰিলে অকমান আৰু ঘূৰি আহিলে বিছনালে শুব ঘূৰি আহিলে এমিশন হ'ব এনাৰ্জি ৰেডিয়েট কৰি দিব নহয় ৰাতিপুৱা উঠি থাকোঁতে মই এনাৰ্জি লাগে নহয় এবজৰ্ব কৰিব সেইটোৱে কথা what I am not মই ইয়াত কি কথা কোৱা নাই Demand energy means এনেকুৱা নহয় যে তোমাৰ বলে যিমানে এনাৰ্জি এবজৰ্ব কৰিব নোৱাৰে যিমান তাক লাগে সি সিমানে এবজৰ্ব কৰিব পাৰে সপোজ 1 ৰ পৰা 2 যাব কাৰণে যিমান লাগে সি সিমানে এবজৰ্ব কৰিব আৰু তাৰ লাইনটো পাৰ্টিকুলাৰলি এক্স এক্সিছত তাতে পৰিব এনৰ যিমান ডাৰ্কৰ ইয়াত ইন্টেন্সিটি বাঢ়ি যায় তুমি এক্স এক্সিছত বাঢ়ি গৈ থাকিবা মই তোমাক আৰু এটা ফৰ্মুলা দিম তুমি এইটো আগতে পঢ়িছা আই থিংক আকৌ মই দিম Dibrugarh formula I think you have studied earlier তার আমি এটা লিখিম তো ফর্মুলা মই দি আছো after that this thing is clear আৰু বুজি পাবা তুমি ওকে বাট ইয়াত মই কি ডিসকাস কৰা নাই what I am not discussing here কি মই এজেনচন কৰিছো কোৱাচোন যোনটো কি ভুল হ'ব পাৰে while describing the absorption emission spectra what I am assuming যোনটো কি ভুল হ'ব পাৰে আৰু অকণ যিমান হি absorb কৰিছে ইমানে হি emit কৰিছে মই এইটো কৈ আছো n equal to 1 ৰ পৰা 4 গ'ল যিমান হি absorb কৰিলে 4 পৰা 1 হওঁতে ইমান হি emit কৰিব but there is a thing A2 I mean atomic physics तो इसमें problem नहीं. But when you study condensed matter physics, there you will see if the system is jumping from one state to another state, তাৰ পৰা আকৌ return নকৰিব পাৰে directly. ভায়া বেলেগ পাথো আহিব পাৰে. Is 4 ৰ পৰা 3, 3 পৰা 2, 2 পৰা 1 আহিব পাৰে. বুজি পালা? সেইটো possibility আছে. এইটো মই কোৱা নাই, মই কৈছো 1 4 পৰা 4 পৰা 1 আহিব. কি 4 পৰা 3, 3 পৰা 2, 2 পৰা 1 আহিব পাৰে. আহিব পাৰে. Those things are also there. That's why the atomic physics, condensed matter physics, statistical physics, all are quantum mechanics always there, all are linked together. But here we will study only pure physics. Okay. Do I have a class on tomorrow? Even if I don't have,